Solution stoichiometry. So we've talked about stoichiometry, and what did we chant for stoichiometry? Grams to moles to moles to grams, right? Let's write that down. Grams to moles to moles to grams. It's like Dora the Explorer, and trying to get to the snowy mountains, and the map tells her where to go, and then she chants it so that she remembers how to get there, grams to moles to gram. Well, sometimes it's more convenient to think about concentrations and volumes instead of masses. So if you take two solutions where you know the volume and the concentration and you mix them together, then it would be hard if you were trying to use masses to do the stoichiometry. And so we can have little variations. We can start with liters of a solution of known concentration. We can convert from liters to moles using molarity. So we could go liters to moles to grams. Or we could go liters to moles and end up with a volume of a certain concentration. Or you could have any combination of these. Nice. Well, I was done with that anyway. So the general path then is volume to moles to volume, where A and B are different substances. They could both be reactants, they could both be products. One could be a reactant, one could be a product. And this part in the middle, this is the part that's common to all stoichiometry problems. It's the moles to moles in the middle. That comes from the balanced chemical equation and the coefficients in front of those substances. So we can do problems like this. How much 0.125 molar sodium hydroxide solution do we need to completely neutralize 0.225 liters of 0.175 molar sulfuric acid solution? Doesn't this look like fun? We have all the pieces we need to do this. We're going to do the same thing we did with the grams, the mass to mass stoichiometry. We're going to take the numbers and we're going to use the balanced equation to organize the information that we're given. So 0.125 molar, well, that relates to the sodium hydroxide. 125, don't write the capital M. Just interpret it and write moles per liter. Write it as a vertical fraction. To make it clear to yourself, this is a conversion factor. The next number is 0.225 liters of sulfuric acid. So we'll write that over here, 0.225 liters. And 0.175 molar, that also relates to the sulfuric acid solution, 0.175. And again, don't write the capital M, write moles over liters. We organize the numbers. What's the question? What are we trying to find? How much sodium hydroxide? What sort of a quantity do you think that is? Is it a pressure or a mass? Probably a volume, right? Because it's a solution. We generally measure solutions by their volume, not by their mass. So we're looking for, this is our question, it's about the sodium hydroxide, and we're looking for the volume, and so the unit on that would be liters. So our path then, because this is involving solutions, is just a tweak on the grams to moles to grams. We're going liters to moles to liters. We're changing the units on both ends. And sometimes it'll only be one end that's changed and the other end's grams. And you'll find that these are actually easier because we don't have to calculate any molar masses. We don't need the molar masses. We're given the concentration, and so there's less side calculations to do. So the volume that we're starting with is the only volume we were given. It's 0.225 liters. Liters of what? Well, liters of sulfuric acid. And it's important to put what it is in there because you don't want to get your moles upside down. So here we're going to have moles of H2SO4, and then we're going to have moles of the other thing, the sodium hydroxide. And then we're going to go to liters of sodium hydroxide. We write out our path, liters to moles to moles to liters. And then we start writing our equation. The units in the numerator are the same as the units in the path, in case you forgot how to do this, which is entirely possible. So then we put in units to cancel out. So we want liters of sulfuric acid down here, so those guys can cancel. And down here we want moles of sulfuric acid, so those guys can cancel. And here we want moles of sodium hydroxide. So we want all the units to cancel out. Dimensional analysis. The units tell you what to do. Now we put in some numbers. The middle one is always really easy. We look at the balanced chemical equation. We find sodium hydroxide. What number is in front of it? It's a 2. So then in our equation, in front of sodium hydroxide, we put a 2. What number is in front of H2SO4? There is no number. What is implied? A 1. So let's put a 1 in here. Now when we were doing the other sort of stoichiometry, then we had to go calculate molar masses for these other two terms. But here we can just use the concentrations. So for the sulfuric acid, it's 0.175 moles per liter. So the 0.175 goes with the moles, not with the liters. I didn't leave a lot of room, so I'll write it kind of cattywampus. 0.175 moles. And then the concentration of the sodium hydroxide, that also will go, didn't leave enough room here either, with the moles, 0.125. And then we calculate. 0.225 times 0.175 times 2 divided by 0.125 equals. The calculator is showing me 0.63. So I'm going to make it come up here, 0.63. How many significant figures should that answer have? It should have 3, because all the numbers that I was given had 3. But my calculator is showing me 0.63. It's not showing anything else. You need to be smarter than your calculator. Your calculator has no clue what significant figures are. And so you need 3 sig figs, you put a 0 here. And that is liters of sodium hydroxide, and that is your answer. Any questions? Colligative properties. Oh, I should start a new section.